Let's take a look at lesson 13.3, volumes of spheres. So far we've already learned how to find volume of cylinders and cones. I would say at this point, do not worry about memorizing the formulas. On the upcoming quizzes or tests, I'm going to be giving you the formulas. All I'm worried about is you knowing how to use them, like what numbers to plug in and all that. So a sphere looks pretty much like a ball, like a basketball, beach ball, whatever. It's that type of a shape where you have the center. Let me zoom in here a little bit. You have the center of your sphere in the very, very center, right? So if you're holding a sphere, it's very difficult to get to the center, but that means that everything on the outside of the sphere is going to be the same distance to that center. Okay. In this first page, don't worry about reading through all this. This gives you the proof of why we have our formula for the volume of a sphere using the last two shapes that we did. So we learned the volume for a cone and a cylinder. Next page is the actual formula. So the formula is volume of a sphere equals 4/3 times pi times the radius to the third power. So it's this right here. Again, don't worry about memorizing just yet. Just know how to plug in our numbers. The only thing that we really need to know is the radius, because we know that we're going to use 3.14 as pi, and that leaves just the radius as the only thing that we need to know. If a problem gives us the radius and it's a sphere, we can find volume. All right, what's going to make this kind of difficult is that fraction that's at the beginning, the 4/3, but I'll be showing you how to deal with that. Okay, let's take a look at our examples, number 2 and number 3 at the bottom. I'm going to do one of them. I'll have you try the other one. Our direction says that we're going to find the volume of each sphere. We're going to round it to the nearest tenth, and we're using 3.14 for pi. So for number 2, I'm going to actually draw what this looks like. A sphere that has a radius of 10 centimeters looks like this. So you draw something that looks like a circle. All right, but this looks like a flat circle. This has no 3D to it. So the way you would kind of make it look 3D is to draw like an oval kind of going around it to give it some depth. And you can even do it this way. This isn't really that necessary, but you can do it also going up and down, kind of like that. And the center is in the very, very middle of this sphere going to the outside, and that's 10 centimeters. So when we're using our formula, we're going to do volume equals, let me do it way above here so that we have some space, 4/3 times pi times the radius to the third power. So that's 4/3 times 3.14 times the radius, which is 10, to the third power. Just like in the last two lessons, we have to do the exponent first. So this becomes 4/3 times pi, which is 3.14, times 10 to the third power. That's 10 times 10 times 10. Right? Know how to do that in your calculator? That's 1,000. And then you just multiply everything out. There's a couple ways to deal with this 4/3 right here that might be a little challenging for some. You can do 4 divided by 3, because that's what a fraction is. It's division, and then times 3.14 times 1,000. Or you can do 4 times 3.14 times 1,000. I recommend, as I'm going through this and giving answers, that you also have a calculator and you're punching this in yourself, so you get used to doing it in a calculator and you're getting the same answer. So if you don't already have a calculator with you, have one out. You can use your phone even. That's fine. But let me go ahead and use my calculator and work through this. So when I enter 4 divided by 3 times 3.14 times 1,000 into my calculator, I get, I'm going to round it as well. So 4,186.7. And remember, this isn't complete unless you have units. It's like you're just trying to figure out how many cubes you can fit in. and we can fit 4,186.7 of these cubic centimeters. And that's our answer. That's our volume. So go ahead and try the next one, number 3. But I'm going to help you out with what the information that's given to you, how to deal with it, because they don't tell you the radius. If you read it, it says it has a diameter of 3.4 meters. Remember, diameter goes all the way. It's actually double the size of the radius. So if the diameter, go and write this down, is 3.4 meters, then the radius is half of that. So we do 3.4 divided by 2. And I recommend putting that into a calculator. Make sure you're getting the same thing as me. That's 1.7 meters. So that's what you're using as your radius, and then putting that into your formula. So go ahead and try this one before you see the answer. Here's a solution for number 3. You can see in blue that I have the formula with the numbers plugged in. I got 4/3 times pi times my radius to the 3rd power. And I had to find out what the radius is from this problem by dividing the diameter by 2. And then after using my calculator, I got this. I had to round it, so it was 20.569 and so on. I rounded it to 20.6. Don't forget your units again. And that's it.